In today's note, we're going to be looking at integers. So integers are positive and negative whole numbers. So for example, -4, -3, -2, -1, 0, 1, 2, 3, 4. So those are just examples that they can continue on both in the negative and positive direction. When we're counting or using or counting integers, we're going to be using counting circles to help us kind of visualize adding and subtracting integers. So we'll use our white circle for +1 and a filled in circle for -1. When we have one of each, or +1 and -1, we consider that a zero pair and that they equal 0. So if I look at my examples, I want to simplify each expression as much as I can. So in order to do this, I'm going to visualize it by drawing my two circles for -2. So two filled in circles, and then two unfilled in circles. And now I want to find as many zero pairs as I can and see what I have left over. So if I look at it, I have one pair, I have another pair. So these get canceled out and these, and all I'm left with is two unfilled in circles or two white circles. So my answer would be +2. Another way you could do this, still visualizing it, draw your sets one on top of another to make it a little bit easier to see what gets canceled out, and then you have your leftover ones +2. So our answer of -1 plus 4, or -2 plus 4, is +2. If we look at example 2, we can do the same thing. -2 minus 3, so another negative, so 3 of them. And if we look to make zero pairs, we can't make any, so that's fine. We now just count up what's left over. So 1, 2, 3, 4, 5. 5 filled in circles, so we have -5. If I look at example 3, 3 plus -4 or 3 minus 4, these are the same thing. So when you have a plus and negative side by side, you can write it as just a negative. So that's why this changes to just that. The steps are still the same. So if I have 3, I'm going to draw my 3 circles. For +3, I have -4. So I'm going to draw 4 negatives. I'm going to make my 0 pairs. And left over, -1. Same thing with the second one. +3, -4. Again, make your 0 pairs. Count what's left over, -1. The answer is the same. So again, it's just changing the form, or the form that we see it. Example 4, 3 minus -1. So something similar to our last question where we had a plus and a minus side by side. So if you have a minus and minus side by side, you can write it as just a positive. So a negative minus a negative becomes a positive, or a minus and a minus side by side becomes a positive. So this can be written as 3 plus 1, which we can visualize as 1, 2, 3, and then one more. No 0 pairs, so this works out to 4. Example 5, minus 2 plus 3 minus 4. Again, even though there's 3 terms now, we can still do the same thing. We could write it out as in steps, so minus 2, then positive 3, minus 4, and then we could find our 0 pairs. So there's one, there's another one, there's another one. This is what's left over, so it becomes minus 3, or I can kind of group everything together. So we have our negative 2, then I'm going to put my negative 4 right beside it. I'm going to have my positive 3, and now I'm going to go through, make my 0 pairs again, and then again I get the same answer. So in the end, again, it doesn't matter how you visualize it, because you should still get to the same final answer. Example 6, again we see a negative and a negative, so we've seen before that becomes a positive. So negative 3 plus 4. So there's my negative 3, positive 4, make my 0 pairs, count what's left over, so I'm left with positive 1. Example 7, 5 minus 2 plus negative 3. We've talked before, if I see a plus and a negative, that has to become a positive, a negative. So I'm going to rewrite this as 5 minus 2 minus 3. And if I want to visualize it, I'm going to have my positive 5, 1, 2, 3, 4, 5, negative 2, then my negative 3, make 0 pairs, and I'm left with 0. There's nothing left over. So again, when you see a positive and negative side by side, the circles are shaded or negative. So basically what we've been doing so far. So example 8, we see a negative and a positive side by side. So that means that this becomes 5 minus 3, which means I'll have positive 5. So 5 on white circles, negative 3, 3 filled in circles, and make your 0 pairs. And that becomes, count what's left over, positive 2. So that's adding and subtracting positive and negative integers. When we're multiplying and dividing, if I have a positive and a negative, my answer is going to be negative. If I have a negative and a negative, it will be positive. And one we don't have, if I have a positive and a positive, I will get a positive. And we can visualize this as well in kind of a box. So if I have a positive and a negative, positive and a negative, so anytime when I'm multiplying and dividing, two positives will give me a positive, positive and negative will be a negative, negative and a positive will be a negative, negative and a negative will be a positive. So if I look at example 1, again I'm trying to simplify or find a solution. So negative 3 times 2, easiest thing to do first is figure out your number. So 3 times 2 is 6. Now look at the sign. I have a negative here and no sign here, which means it has to be positive. If we go back up to our table, a positive and a negative will give me a negative. So negative 3 times 2 is negative 6. If I look at example 2, 4 times 6, I'll focus on just the numbers. 4 times 6 is 24. I look at the sign, they're both positive, so I leave it as positive. Now, example 3, negative 5 times negative 8. Looking at just the numbers, it's 40. Negative times a negative If I look at my table, a negative and a negative will give me a positive. I don't need to show that positive, but if it helps you, you can. And if I look at example 4, negative 7, positive 9, let's look at just the numbers first. So 7 times 9 is 63. Negative times a positive means I have a negative. And that is what we're going to cover looking at integers.